Hello, and welcome to the Learning World.
Today we'll be doing problems 6 through 10 of the AMC 10A 2021.
So let's begin.
Problem 6 reads, Chantal and Jean start hiking from a trailhead toward a fire tower. Jean is wearing a heavy backpack and walks slower. Chantal starts walking at 4 miles per hour. Halfway to the tower, the trail becomes really steep, and Chantal slows down to 2 miles per hour. After reaching the tower, she immediately turns around and descends the steep part of the trail at 3 miles per hour. She meets Jean at the halfway point. What was Jean's average speed in miles per hour until they meet? So let's start off by getting a rough sketch of the trail, which is indicated by these two lines, and where I showed the middle point is where it becomes the steep part. So here we have this arrow, which is Jean's trail, since she only goes halfway, whereas Chantal, she walks to the halfway point, up the steep part, and then back down to the halfway point. And that's where in the middle they meet halfway. So here, we need to remember that distance equals speed times time. And this formula will help us solve this problem. So here we can rewrite this problem as this formula as distance over speed equals time. So now we can use this formula as distance over speed, since we know that let's say D is halfway of the trail. So Chantal, she starts walking at 4 miles per hour in the first half of the trail. So we can put that as D over 4. Next half she walks at 2 miles per hour, which is D over 2. And finally she turns around and starts walking at D over 3. So basically 3 miles per hour. And the time she takes is equal to 13D over 12. So since we have this time, we can just say that D over 13D over 12 equals 12 over 13. Now where did I get the D from?
Okay, so we switched the equation distance equals speed times time and rearranged it to speed equals distance over time. So that way, the distance, which is D, that's Jean's trail. And then Jean traveled the distance D, and the time, same time as Chantal, that's 13D over 12. So the speed of Jean must be D over 13D over 12. Now once you simplify that, that's 12 over 13. And that's the answer A. Problem number 7. Tom is a collection of 13 snakes, 4 of which are purple, and 5 of which are happy. He knows that all of his happy snakes can add, none of his purple snakes can subtract, all of his snakes that can subtract also can't add. Which of these conclusions can be drawn about Tom's snakes? So A, purple snakes can add, B, purple snakes are happy, C, snakes that can add are purple, and D, happy snakes are not purple, and E, happy snakes can't subtract. So out of these, let's keep on let's do process of elimination. So A can be cancelled off because purple snakes can add. That's not true. It's already clearly stated that none of his purple snakes can subtract, and they can't also add because they can't subtract. And then we can cross eliminate B too because purple snakes, if they were happy, they could have added. So they're not happy. Okay, and then we can cross eliminate C because it's basically B, but just saying it in a different way that snakes that can add are purple. They're not purple at all, and they're not all of them will be purple anyways, because it's the converse of it. Number D, we can't eliminate that, but we can eliminate number E, which is not number E, which is option E, which is happy snakes can't subtract, because it already says happy snakes can add, and all of the snakes that can't add can subtract and also can't add, but it doesn't say anything about that happy snakes can't subtract, so he can't draw that conclusion. The only conclusion he can draw is D, because happy snakes can add and purple snakes can't add. So D, it must be the final answer.
Let's move on to problem 8. When a student multiplied the number 66 by the repeating decimal 1.AB with a bar notation, where A and B are digits. He did not notice the notation and just multiplied 66 times 1.AB. Later he found that his answer was 0.5 less than the correct answer. What is the 2-digit integer AB? So first let's start off by defining some things. So 0.AB with the bar notation is equal to AB over 99.
a way to prove it is by using a system of equations. We're not going to show that here, but you can find that out in a different time.
Yes, so now let's move on. So we know this, and let's say AB equals X in this case, right? So let's make this equation here, where we say 66 times 1 plus X over 100 plus 0.5 equals 66 times 1 plus X over 99. So here what we're saying is, on the left side of the equation, we have 1 point AB without the bar notation. So here we are multiplying 66 times 1 point AB, and that's going to be 1 plus X, which is AB, over 100. And since that answer is 0.5, the student's answer is 0.5 less than the correct answer. That means we have to add 0.5 to the correct answer in order to make it equal to the other side, which is going to be the correct notation, where we add the bar notation. Here we can say 66 times 1 plus X over 99 is going to be what was the correct answer, which he was supposed to find. So here we can just solve. So we basically use the distributive property in this step, and we have to just continue solving the equation. Here we get 33x over 50 plus 0.5 equals 2x over 3. And we can just continue solving. 99x plus 75 equals 100x. Finally, we get that 75 equals x. So therefore, we can conclude that E, 75, is the correct answer.
Problem number 9. What is the least possible value of xy minus 1 squared plus x plus y squared for real numbers x and y? So what we're trying to do in this problem is simplify this expression. So now, the way to simplify this is to make first first distribute everything. So it becomes x squared y squared minus 2xy plus 1 plus x squared plus 2xy plus y squared. Then, because the 2xy's cancel out, we can simply make it x squared y squared plus x squared plus y squared plus 1. Because we know that the squares of any number must be positive, the maximum, the value we need for x squared y squared plus x squared plus y squared for real numbers x and y, the minimum value we can have is 0, because squares must be non-negative, not positive, but non-negative. That's only when x and y are both 0. So that way, we get the minimum answer of 1. And that's the answer.
The last problem we're going to discuss is number 10, which reads, which of the following is equivalent to 2 plus 3 times 2 squared plus 3 squared times 2 to the 4th plus 3 to the 4th times 2 to the 8th plus 3 to the 8th times 2 to the 16th plus 3 to the 16th times 2 to the 32nd plus 3 to the 32nd times 2 to the 64th plus 3 to the 64th. So this is a lot of numbers, and it might not look like we can simplify this at first, but we can use this theorem here. So the product of differences. So here what we're saying, that x plus y times x minus y is equal to x squared minus y squared. You can check this by foiling x plus y times x minus y, first, outer, inner, last, and you will get, when you simplify it, you will see that the middle term cancels out, and we are left with x squared minus y squared. So after we find this, we basically need to, if you look at this, we have all the addition expressions here in a problem, but we don't have the subtraction. So the subtraction part, we need to add that. So what we do here is we rearrange what we have in those parentheses to make sure that the 3 comes first and then the 2 comes after that. So basically like 3 plus 2, or 3 squared plus 2 squared. That way we can multiply the whole expression by 3 minus 2, which is equal to 1. So technically we're not changing the value of the expression in any way. So now that we have 3 minus 2, which equals 1, we can just use this and simplify the expression even further. So using product of differences, we can say 3 squared minus 2 squared is basically equal to this 3 minus 2 times 3 plus 2. And as we continue down, we find we keep simplifying this. You can pause the video if you need to look at the simplification further. But in the end, we get that 3 to the 128th power minus 2 to the 128th power is the answer. So that answer is C.
That's it for this video. We hope you enjoyed it, and thank you for watching.